So sine was y over r, cosine was x over r, tangent was y over x. Cosecant was the inverse, secant was the inverse, and cotangent was the inverse. R over y, r over x, x over radius. Now, when I was talking about yesterday, asking you guys to find the values on the quadrantals, I was asking you to go through the 6 trig functions that you get at 0, pi over 2, pi, and 3 pi over 2. So this was at 0, 1. Right? So if I'm looking at the quadrantals and I want to write out the 6 trig functions at 0, well, 0 has the ordered pair of 1, 0, x and y. What's the radius there? 1. The radius is 1. And this value here is also 1. So it's a matter of just going through and solving. So that means you have your cosine. I should start saying cosine first because it corresponds to the x value. It's a little bit quicker. What's the cosine at 0? It's 1. Because it's 1 over 1. What's the sine of 0?
0.
It's 0 over 1, so it's 0. Tangent.
So
It's also 0 because it's sine over cosine, so it's 0 over 1. Okay. Now you do your inverses. The inverse of cosine is cosecant. Oh, sorry, not cosecant, secant. I did cosine first. You did. I said cosecant, but I meant to do secant first. So what's the inverse of 1? 1. The cosecant here, though, it's undefined because the cosecant of 0 would be 1 over 0, which is undefined.
Wait, are you doing this like on this video?
Yeah. And then same thing, the inverse of tangent is cotangent, which is also 1 over 0, which is undefined. Okay. Last year, one of the things that I remember from my classes is that quadrantals were a pain in the butt. And I don't know why. I always thought the quadrantals were the easiest. You didn't have to do any work. Am I right?
Yeah.
But you guys always...
Didn't remember.
Well, good. Well, you still remember or you didn't remember?
Didn't remember.
Oh, I thought you said you
Yeah,
still... I thought you said... I thought you said still remember. I'm like, oh, good. And then you made me feel
I
bad.
didn't remember them to begin with, so
Well, second time's charm.
yeah.
I thought it was
It's Jedi. We're hoping for the best.
Hey,
I'm joking.
class.
All right, and then we do the same thing going to tangent. All right, when you go up to tangent, or excuse me, pi over 2. Guys, when I go to pi over 2, my x value is 0, my y value is 1. So what's the cosine? Cosine is 0. Sine is 0, pi over 2. What you should have done yesterday for your homework. Tangent of pi over 2 is going to be undefined. It's 1 over 0, so you have undefined. Now, I'm going to jump ahead real quick to what we did after we worked on unit circle and solved all those equations and did all that kind of junk. Remember when we graphed them? Remember when you guys all graphed sine, cosine, and tangent? When we graphed sine, cosine, and tangent, one of the things that you guys saw that when you graphed either sine or cosine, and it was periodic. it repeated itself back and forth. Also, cosine was a sine graph shifted pi over 2. I don't know if you remember that as well. So it just went up, whatever, it's not right, but you get the idea. But the oddball was tangent. What was the period of tangent? It was pi. It had asymptotes. And the reason that it had asymptotes is because it was undefined at values, whereas sine and cosine was a continuous function. Tangent had those asymptotes that it could not occur because it had undefined value. That's why this happens. At pi over 2, you can't divide by 0. That's why tangent is undefined at pi over 2 as well as 3 pi over 2. Okay? That's why that didn't work, if you guys remember that from graphing. Whereas sine and cosine, they all kind of went up and came down, up and down, all the way around the circle. Okay? And then inversing these guys through, what's the inverse of 0? Undefined, you just flip it. Inverse of 1? 1. Inverse of undefined? 0. You guys might remember that when you did slopes. I mean, this has nothing to do with slopes, but the opposite reciprocal of a 0 slope was an undefined slope, so horizontal lines were perpendicular to vertical, that whole thing. Same basic idea here. Okay? All right? And then what changed when you went to pi?
Negative.
Things became negative, right? So at pi, your cosine was negative 1. Your sine was 0. Your tangent was 0. Now, what's the inverse to negative 1? It's still negative 1, remember. It's not opposite reciprocals or anything like that. It's just the inverse. Okay? The inverse of 0, and then the inverse of, yeah, it's inverse of 0. That's, yeah, so you want to find. And then you go down to the last one. At 3 pi over 2. Cosine is 0. Sine is negative 1. Tangent becomes undefined again because you can't divide by 0. And then if you inverse all of that, you have the secant, the inverse of cosine, is also undefined. Cosecant still is negative 1. And then the cotangent is going to be at 0. Okay. Now, this year, not only are we going to graph sine, cosine, and tangent, we're also going to graph cosecant, secant, and cotangent. Okay? They're just inverses of one another. And I think I remember showing my guys how we did this in honors. For example, just real easy, sine has a period of 2 pi. Remember that? 2 pi would be out here, halfway is pi, pi over 2, and then 3 pi over 2. We started at 0, went to 1, 0, negative 1, and 0, and we did this. Oops. Okay? Whereas if you did it the other way, think about cosecant. Cosecant at 0, well, the inverse of 0 is undefined. So at 0 would be undefined. Cosecant is the inverse of sine here. What's the inverse of 0? Oh, I labeled it wrong. I'm sorry. It's supposed to be 0, 1. Excuse me. What's the inverse of 1? Sorry. So it's at 1. Going back to the other side, if we're at negative 1 and 0, the inverse of 0 is, so you'd have another asymptote. Then you'd come back here to negative 1. So what happens for a cosecant graph, it's just the inverse of the sine graph. And that's the stuff that we're going to do. You graph things like you would normally, when it's critical values, those 5 points you guys used to plot during the periodicity of it, you just do the inverses at those points. And that's how you create the other graphs. It's actually pretty easy. It looks like it's god-awful, but it's pretty simple. I gave you guys, did I give you?
No.
You're reminding me. Thanks.
Sure. You don't need to.
No, it's just a lot of.
So I need to remind him to remind you.
I don't know. I haven't decided yet or not. So the other thing.
Wait, we're supposed to take a quiz on this?
No, I decided no.
Yeah, quickly.
One of the other things I wanted to go through today is to remind you guys how things bounce within the quadrants, because depending upon where you land on the unit circle, each one of those values work. Okay. For example, if I want to figure out what is the sign at 5 pi over 6, I need to find its reference angle. Remember doing that?
Yeah.
So what we do is, the easiest way, draw your quick plus sign, and then realize that here is pi. 5 pi over 6 is how far away from pi? Pi over 6 up. So its reference angle is pi over 6. Pi over 6 relates to which degree angle? 30, good. So if I want to look at that, I'm talking about the sine of 30 degrees. The sine of 30 would be 1/2. Would you be okay with that? The sine of 30 is 1/2, but what quadrant am I in?
Second.
Is sine positive or negative in the second quadrant?
Negative. Positive. Positive.
Remember, positive, positive, for cosine, sine, negative, positive, again, cosine, sine, negative, negative, cosine, sine, and then positive, negative, for cosine, sine. There's a lot to remember that you had built into the unit circle. Okay, there's so much that was left in there from before, and being able to bounce into finding the reference angle is how you're going to be able to calculate positives or negatives, and you're only going to be bouncing within those two different triangles. Okay? It's a matter of being able to spin it around enough to see which one it winds up in. Okay? Let's try another one. I had some. I never given a pre-calc final before. Yes. That's what Fontana told me. You walk in with a course report, we got problems.
We get a note card? Yeah, one for each chapter. Wait, do you still have all of our note cards? You could like give us all of our note cards back, that's what you're using, that's what we do. Yeah, just save them all. Yeah. One for each chapter.
3 big ones.
Okay. So let's look at this. I want to figure out what the cosine of negative 11 pi over 3 is. Do you guys remember what's the negative mean? I go the other way. Very good. Okay? I have to go the other way. Now, I'm not going to lie to you. I hate mixed numbers. I think they're stupid. Okay? They're stupid. This is one of the few times that I think using a mixed number kind of helps you count the amount of pi you need to unravel yourself to figure out what your reference angle is. Correct. So I'm looking at this. This is 3 2/3 pi, but it's negative. Correct. So what we do is we count pi. Ready? I hear you, some of you guys. Ready? 1 little, 2 little, 3 little pi. And then I go 2/3 more pi. So 2/3 more, is that more than halfway or less than halfway? How much pi do I have left to get to the bottom there?
1/3.
Pi over 3. So my pi over 3 is my reference angle, which is 60 degrees. And is it going to be a positive or negative value in the first quadrant?
Positive.
Both positive. So in a 30, 60, 90, We have 1, 3, and 2. I'm looking for the cosine. What's the cosine of 60 degrees in the first quadrant? 1/2. That's the idea of being able to spin yourself back in and around in the unit circle to figure out where your reference angle relates to. And yes, we sang dumb songs and we did stupid things, but it works. Right?
Your childhood.
Yeah.
We do it all the time. Yeah. Let's do this one.
You don't need a license to drive a sandwich.
Let's do the cosecant of 23 pi over 6. You ever had to talk to me? I was walking up there. Yeah, 23 pi over 6. So cosecant 23 pi over 6. How many times does 6 go into 23? 6 over 3 and how many?
3,
Some change.
5, 6.
3 and change. 3-ish, right?
No, it's actually closer to 4 than it is
So it's still 3, 5, 6, right? Yeah. So it's positive, which means we spin it going counterclockwise. So we sing the song. 1 little, 2 little, 3 little pi. And I have to go 5, 6 more. What's the reference angle? Pi over, not negative. The reference angle is just bounce. How far am I bounced off? I'm bounced off pi over 6. Which means it's which angle?
30.
30. What's the cosecant of 30? 2. Now is cosecant going to be positive or negative in the fourth quadrant?
What?
Negative, very good. It's negative down here because it's positive, negative. If sine is negative, cosecant's negative, so your answer is negative 2.
Can you, well, I'm at, the reference angle is pi over 6.
Yep.
And then how did you, yeah, I'm confused how you got the 2 as well.
Cosecant is the inverse of what trigonometry?
Cosecant is sine.
Sine. So the sine at 30 is 1/2. What's the inverse of 1/2?
Oh.
2 over 1. Okay. It's negative, and this is what you might not have written down yet. Remember, your sine, your SIGN value, cosine positive, sine positive. If cosine's positive, secant's positive. If sine is positive, cosecant's positive. Here,
Okay.
it's cosine negative, sine positive. Cosine negative, sine negative. Cosine positive, sine negative.
I got it.
Now, the only other trick was, where was tangent positive and where was tangent negative? Remember, tangent, guys, come on. Tangent is y over x. So tangent will be positive whenever both signs are positive or both signs are negative. Because what's a positive divided by positive? What's a negative divided by negative? And so tangent is positive here. Tangent is negative here. Tangent is negative here. And tangent is positive here.
So it's positive in the first one and negative in the second.
Correct. Therefore, cotangents will mirror it the same way because they're just inverses. They're just flipping the fractions. It doesn't matter what their signs, SIGNs. Okay? So one of the reference ones, it's fine. All right, let's do cotangent. Negative 13 pi over 4. If I go cotangent of negative 13 pi over 4, first thing I figure out is how many times 4 go into 13. So it's 3¼ right?
Yeah.
3 pi over 4, but it's negative. So we spin it. 1 little, 2 little, 3 little pies, up a quarter pi.
Oh, I went the wrong way.
Pi over 4s are always reference angles of 45 degrees. Now, when you have the 45-degree angle, the tangent and the cotangent are always going to equal what? 1. Tangent of 45 is always 1 because it's opposite over adjacent. Cotangent would be adjacent over opposite. It's still going to equal 1. Bless you.
Thank you.
But in the second quadrant, is cotangent going to be positive or negative? Negative. So your answer here is -1. It's a matter of spinning yourself in and around to identify which one of these 3 angles you get, or a quadrantal, to decipher the trig function.
These are easy, but they're easy to mess up.
Yeah, you just got to know how to count.
I know I can't do that.
Yeah, you're
Sometimes I think about running and then I think about running and I say no.
cosine of 9 pi over 4.
We got 2 1/4 pi.
2 1/4 pi, good.
This is gonna be a boring count.
1 little 2 1/4 pi.
7
First quadrant.
Yes.
What's cosine of pi over 4 in the first quadrant?
45. Zone 1.
So we have, it's cosine, not cotangent.
Oh,
Root 2 over 2.
So you do your opposite, or excuse me, adjacent over hypotenuse. So you get 1 over root 2, which is
Root 2 over 2.
root 2 over 2. Okay. See, the pre-calc didn't have as many examples as this.
Let's play quick share. What's that? Guess what? Get very ready before tomorrow.
I got the button.
I'll draw it later.
Just like Jen. He didn't know what hit that.
All right, so in 4-2, I'd like you to do this. Just for today, we're going to talk about the even and odd parts of this tomorrow. 29 through 36.
Yeah.
You're doing the six trig functions at a specific point that you're going to have to spin yourself around to get the right reference angle. Okay? The spin around angle, yep. The way the pre-calc book talks about it, it doesn't really talk about the way that we get the reference angle like I show you guys, about how to count yourself forward and backwards. It talks about just adding and subtracting 2 pi all the time. It works just the same, but I always found that it's easier to walk yourself around because it's more visual. Okay? I just always thought it was a little bit more visual to do it that way. So if you want to go via what they do in the book, go for it. If you want to do it the way that I'm showing you, go for it. Let me give you guys that problem set that Fontana had for the some of the breakdown good problems reviewed for the final.
Should I write them?
You're itching. You're itching for it.
I got it too.
Yes, on offense.
No, I didn't. No, I guess almost did like half the final last year.
That doesn't happen to me when I'm not smart.
Well, no,
Don't
just
they see, like they see.
I would be actually.
It's the one that I have used.
Yeah.
I think the one that looks
Or you can be like Ryan.
or like if I get an answer and it's not.
Obviously, there are some problems on here.
To what I got.
We did not cover, we did not go into 4-3-4-4 because we kind of ran out of time. No big deal.
If we didn't have
Because we
time.
didn't do it.
Well, we still got two more
Jefferson?
diddly dudes.
So, what we'll probably start doing Friday, I bet, is just doing problems.
Are you for real?
I don't think you're gonna need to worry about the 365 page. We did not get there. Surprised there isn't anything on 290. There are some stuff I'm gonna adjust, because I know obviously there are some things you can do. You can go ahead and right off the bat and cross off that what's 360. Well, before you do anything, ask what 365 is.
4 1/4 worth of chapters for compared to this issue, 22.
What is
What's your grading?
On the part on the page where it says 365, go ahead and cross off for everything from 45 onward.
Cross off these,
They are not like.
not 1 through 19.
35 or 45, cross out 45 or 45.
Yes, starting at 45, because we haven't done those. That's different sections.
I have.
Yeah, we haven't gotten there. But what I would put in there is to put in, let's see, 25 through
There goes my high.
35. And just do like odds that we can check the book, okay? So on the 365 chunk on the very bottom, that review part there, one, 2, 19, 23. Then cross off everything after that. Change that to 25, 35, odd. Okay? That's going to basically leave us with what we're working on today and tomorrow, talking about how you get the reference angle, the value of the trig function, and then how do we find the even and odd parts of it. We'll start off with the second semester with the rest of the junk.
So we're only allowed to have one next year.
Yes.
Like just a note card.
Yes,
Yes, but just give them all back.
Yeah.
But I
Because he secretly.
yeah.
He secretly kept.
It's no secret, they're gone.
His wallpaper in his house.
Yeah. Yes, yes. Connor and Ryan are fighting over this. I want to learn more math. They're really not.